Hey everybody, I wanted to take some time and go over Brown-Lemay-Burston question number 20.18. And so this one is interesting because it is asking us to discuss which elements in the redox reactions are undergoing changes in oxidation number, and then we get to identify the magnitude of the change in each case. Okay, so let's take a look at some of these problems. Okay, I think that one of the more straightforward things to do is look at the elements. I always like to look at the elements first, and then look at what it looks like on the other side of the reaction. So if it's a product, I'll look at the reactant side. If it's a reactant, I'll look at the product side. But here we have sulfur for going from 2-. So for sulfur, for A, sulfur is going from 2- and it's going to 0. So that is a change. Let's see. That's an oxidation. So that's a loss of 2 electrons. Okay. Now the other one that's changing, okay, it's not going to be hydrogen, it's not going to be oxygen. Okay, it's not going to be oxygen, it's going to be manganese. So here manganese is a 7+, and manganese here is a 4+. So manganese is going from a 7+ to a 4+, so it's gaining, this is our reduction, okay, it's gaining 3 electrons. Okay, but the magnitude of this, because this is 2 and this is 3, this has to be least common multiples. So this is going to be 6 electrons and 6 electrons, because you have to take this and you have to multiply it by 3, and take this and multiply it by 2. Okay, now for part B, okay, part B, let's see, here's an oxygen. So if we have oxygen, let's go from oxygen here, let's see, and oxygen here, that's all sorts of things going on. And we have chlorine and chlorine. So let's, hydrogen is not changing its oxidation states. So oxygen is. So oxygen is going from in O2, H2O2, oxygen is a 1, 1-, and it's going to a 0, because that's what that is. Oxygen is also going from a 2- to a 0. Okay, in here. But I think that we're not going to worry about this guy because it's a base catalyzed reaction, and so this is probably what we're going to use in here. Okay, to this oxygen is going to be that one, because there's some oxygens that's being, let's see, it's 1- to 0. So that's some oxygen that's being oxidized. So some of the oxygen is being oxidized and some isn't. Okay, here's another one that's being oxidized, that's involved. Okay, so because there's all sorts of oxygen there, my guess is we're going to keep some of it at the 2-. Okay, and so this is the one that's undergoing the change. Okay, and now we look at the chlorine. Now when we look at this chlorine, Cl2O7, let's see, oxygen is a 2- normally, and so that means that chlorine is a 7+, and then here for the chloride ion, it's going to, let's see, this is 4-, because there's 4- because there's 2- times 2, so this has to be a 3+, so that's what's being reduced. So this is a change in 1, this is a change in 4, so the overall change is 4 electrons. Okay, so let's take a look at C. Again, here is oxygen, and oxygen is present in all of these crazy things. Okay, so some oxygen is going to change oxidation states, others isn't. So here, we're going to look at the funny oxygen, the one that's the peroxide. So that, for question C, the peroxide, again, is going from, in the oxygen atom, is going from 1- to 0. Okay, and that's what's being oxidized. Okay. Make sure I have that right. Yep. Okay. And now the other thing that's undergoing a change, let's see, barium is 2+, barium is 2+ here. Oxygen we already dealt with. Hydrogen isn't going to do anything, so it must be the chlorine. So in this case, the chlorine here, chlorine is a 4+, and that's going to a, let's see here, there's 2 of those, so this is a 1-. Chlorine is a 3+ in this case. Okay, right, yeah, okay, so, and that's being reduced. So here this is changing by 1 electron, this is changing by 1 electron. Those are the same coefficients, so that means that there's the magnitude of the change in the number of electrons is 1. Okay, so that is question number 20.18. Have a great night.